Sobi Salman along with my partner Nasir Nisar, who created the codes, and Tuba Arshad, who helped me in creating this video and presenting it to all of you. The topic today we'll be discussing about is data analysis and visualization on Jupyter Notebook. So, first of all, we'll discuss about what is data analysis. Data analysis is the process of systematically applying statistical and or logic techniques to describe and illustrate, condense and recap, and evaluate the data. Using a simple example, I'd like to tell you what is analysis. Just think about when you are making any decision, you think about your past or what circumstances it will have on your future, and then you take that decision. That means you're analyzing our past or future and making decisions based on it. The importance of data analytic is steadily growing all across the world and industries. So having proper data analytic and visualization tool has become very important. Jupyter Notebook is one of the leading open source tools for developing and managing analytics. What is Jupyter Notebook? Jupyter Notebook is an open source web application that provides an interactive computational environment. It produces documents that combine both input and output into a single file. Single document approach enables a user to develop, visualize the result, and add information, charts, and formulas that make work more understandable and shareable, obviously. So let's get started with data analytics. Let's move on to a Jupyter Notebook. Now in this video we'll be discussing about how we can upload a file or how we can create a new file, and then how we can analyze our data and visualization as well. So this is my home page of Jupyter. I have already opened it in my browser. If you have an already created a data, if you already have a data, you will click on upload, go to show all files, and select the required data you want to work on. But I have already uploaded my data here. You can see I have German credit data, that is the title of our data set. If you want to create a new file, you will be directly navigated to a new tab. Here you can give title to our document and then start typing your code. These are the cells in which you can see it's written in here. You give your input codes over here. Then when you click on run, it will show you output in a different cell. But we're not creating codes over here. We will be working on real world data. That this is the data set that I'll show you the data set that I'll be working on. See, this is the data set that I will be working on in today's video. This is the data of German credit data. German credit. You can see this data. It's a really large number of data. I'll try to show you the last row. Here you can see there are a total of 1001 rows in it, and there are a total of 11 columns in it. Okay, so when we're working on this kind of large amount of data, the Jupyter is the best thing, or you can say Python is the best thing to work on it, to clean the data, to analyze it, or to present it visually. So what is the problem we are having? The first phase of this project is to see what is our data made about, like the key features of data and where are the null values, how to clean it, and everything. Which variables are numerical or categorical, and which columns have null values, which is something we will address in the feature engineering phase. We'll talk about all these things in our today's video. First of all, we need to understand our data. What do you mean by understanding our data? See, before working on any data, you need to import some basic libraries. So here we'll import pandas as PD, matplotlib as plt, and import numpy as np. Matplotlib is a library that is used for visualization. We will also use Seaborn in this video. We have used pandas and numpy because these are for data exploration. Now the features that this our data have is age, that is numeric, gender, that is text, job, that is also having numeric data, housing, that has text, and here you can see all these purpose, text, duration is in numeric, credit amount is numeric, checking account is numeric, and saving account is text. So let's start working. After importing the libraries, we will load our data into the system. How can you load our data? You can see this gc underscore data, that is, I have created this variable, and pd.create underscore csv. This you have, after creating this code, you will upload your file over here. Your file should be in .csv format, or else you will not be able to run it or work on it using Python. Now what I have done, I used print command, print gc underscore data dot columns. What will it do? It will show all the columns of your data. Then I used gc underscore data dot head. Why do we use this? Dot head command is used when you want to see only top 5 rows. Like in series, starting from, you can see when I run this command, it showed me top 5 rows of my data, starting from 0 to 4. This is all 5 rows, and all the columns are here of my data. So now when you know the columns in your data, when you have seen the data, you will go on descriptive statistics. What is that? You will work on the shape of your data. Let me show you that. Okay, here, descriptive statistic, we will work on what is the shape of our data. First of all, we'll print shape of credit card data set is, I have kept this in double inverted commas so that it will be printed as it is. Then gc underscore data dot shape. Dot shape, what will dot shape do? It is a tuple of integers. The shape of data is a tuple with the numbers of elements per axis dimension. In the data, we have 1000 entries and 11 columns. See here, it is showing you. Then gc underscore data dot info. This gives you information about your data, like the numbers of columns, the label, data type, memory usage, range, index, etc. etc. Then I use gc underscore data dot describe. Dot describe shows the count, mean, standard deviation, mean values, and percentages of different columns. I'll show you the output. See, here you have the count, mean, standard deviation, minimum 25%, 50%, 75%, and maximum of all the data sets over here. All the data, all the columns over here. Now after we have see, first what we did, we understand our data, we just what we did, God. Now when we know the shape of our data, we know how many columns are there, so now when we work on cleaning our data, how will we do that? First of all, we have to find if there are any null values in our data set or not. For that, we'll use gc underscore data dot is null brackets dot sum. What will it do? It will show you that which column is having null cell values. Just like it's showing you that there are 0 nulls in unnamed column. In each column you have 0, sex, job, housing, all are having 0 null values. But saving accounts and checking accounts are having the number of null values in it. Let's see if it is telling you the correct answer or not. See, let me take you back to the top. You can see checking account. In this column you are having NA, NA, NA. This NA is showing you not available or null values of your account. And similarly in saving accounts you can see there are also multiple null values in it. So that means our code is working correctly. Now when we know that there are few columns that are having null values, obviously we have to remove it. We have to fill those null values with some values. So why do we need to remove the null values? Removing null values is very important step as the value affect the performance and accuracy of any machine learning algorithm. If you will not remove the null values, the data will start showing errors in it. Now what we'll do, we'll print the unique value purpose is that. Now we'll printing unique values of this. What are unique values? Unique function is used to find the unique elements of an array and return the sorted unique elements of an array. See, just like we are using gc underscore data. Why are we using this? Because we have we have saved our file or our data in this variable. So we'll use dot purpose dot unique dot sex dot unique. We are this purpose, this sex, housing. These are all the name of our columns, if you remember that. Okay, and now we are applying this unique function to it. Why? So that it can figure out the unique values in this. What will it do? It will call out a unique value from these, and then it will fill it in our null values. Okay, then moving on, separate categorical and numerical columns. Why are we separating it? So that we can work accordingly. Okay, so because working on categorical columns and numerical columns require a bit of different algorithms. Numerical is equals to credit, amount, age, and duration. Now we have saved these three columns in numerical variable, and categorical variable we are saving sex, job, housing, saving account, checking accounts, and purpose. All the columns that had numerical values we have saved in numerical, and all the columns that had categorical values we have saved them in categorical variable. We have one more column that was unnamed. I'll show you again. See here, it is not assigned any name, so we took it as unnamed, and it is just having series. You can see that it is only showing us the series or the number of list. So it is unnecessary to keep it because it is not going to help us in any way in visualization or analysis of our data. So what we'll do, we'll drop this column from our data. gc underscore data is equals to gc underscore data dot drop. Dot drop, what will dot drop do? Dot drop will delete this unused column from our data. Now again we have used gc underscore data dot shape to check the shape of our data again. Now you can see earlier we had 11 columns and now it is showing you 10 columns because we have removed one from it. Moving on. Okay, now we'll fill the missing values. For cat and categorical, we have created this function. gc underscore data cat is equals to gc underscore data cat dot fill na. What does fill na do? Filling, first of all, we need to know that why we need to fill these values. As I told you earlier, that if we not fill these values, it will create errors in your data. Filling the values will calculate the mean of the column and fill the missing values. What does fill na do? Fill na will calculate the mean, median, or mode of that particular column, and then it will fill the NA or not available cells with that mean, median, or mode, whatever you have calculated. You can fill the missing values with mean, median, or mode depending on the requirement. But as we are working on categorical data, we are working on categorical columns, so we'll have to use mod. Okay, we'll be using mod. Now we have used gc underscore data dot is null dot sum. Why we used dot sum? Dot sum returns the number of missing values in the data set, and is null will fill these data sets. Now you can see there are no null values in it. You can see is null shows us the number of not available cells or empty cells in our data, and you can see that there are no empty cells left in the data. It's all showing 0 over here as there are no null sets available now. We have cleaned the data, we have sorted all the null values, we have filled them with the mod. Now we'll see how our data looks after that. So for that, to display the categorical data, we'll use cat, that was the variable we created, is equals to gc underscore data dot select underscore dtype. What is dtype? Dtype returns series with data type of each column, including the object data type. Now this whole thing is saved in the variable cat include is equals to object dot column. Cleaning our data after filling all the null values with the mod. Now we'll see how data looks after that. So to display categorical data, we use cat as a variable is equals to gc underscore data dot select underscore dtypes. What are dtypes? Dtypes return series with the data type of each column and include the object data type. What is include? Include is the function that calls a function from another Python file. Now after creating this variable, we called it cat underscore gcd. Before calling it, we created another variable cat underscore gcd and saved this variable into this. Okay, because we worked on this variable, then we saved this cat variable in cat underscore gcd and called this function, this data, and see these are all 6 columns that had categorical data in them, and they are displaying over here. You can see a number of columns. They are showing all rows over here. So you can see that there are no null values now available in it. You can see all the null values are replaced over here with the moderate, or wait a minute. Yeah, you can see the quite rich, moderate, rich. It has replaced all the null values depending on the mode of that column. Now moving on. Now we'll work on our numerical data. So for displaying numerical data, we use the same thing, but now we'll exclude object. We are not going to include it anymore. Then we created another variable to save our numerical data, and when we display it, you can see that here are all the numerical data that we had in our file. Now we know that there are no null values in our data. Now we have cleaned the data properly. Now we can work on visualization. Before working with pair plot and subplot, we'll be talking about heat maps. What are heat maps? Heat map create correlation to marks the repetitive value for each pair. For creating a heat map, what will you do? You will again use plot.figure, and figure size we have kept the same, 20 to 15. sns.heatmap to create the chart of heat map. We will use the same data, gc underscore data dot core. What is core? Core is used to find pairwise correlation of all column in data. then annotation will be equals to true. And color map, we use this color. This you can use any color of your choice. Then we again use plot.show to plot our graph over here, and you can see the plotting. What is over here? What is the main thing over here? That when non-numeric data type column is ignored in it, all the data type, all the columns that were having non-numeric values will not be included in this heat map. And when the correlation is formed by the same columns, like here you can see, wait a minute, let me show you from below. See, creating amount, if correlated with created amount, it will create, gives you 1. Duration along with duration will give you 1. So when the correlation is formed between two similar columns, it will give you the answer 1. Now here the heat map shows best correlation between credit card and duration. How do we know that? See, the duration correlated with credit amount gives 0.62, and that is the highest value in this whole heat map. Can you see that? That is the highest value here as well. Credit amount with duration gives the highest value, that is 0.62. So that is the best correlation formed with heat map. After heat map, we will talk about box plot. What is box plot? Box plot is created to display the summary of the set of data values having properties like minimum, first quartile, median, third quartile, and maximum, etc. Box plot are a measure of how well distributed the data in a set is. You can see we again use figures equals to plot.figure, and the figure size here we use just 15 and 10. Again we give it an axis, that is 220 this time. Now for num in numerical, we are using different variables over here now. Axis plus is equals to 1. Fig dot add underscore subplot axis. This is the same format that we used before. SNS dot box plot, we are now using box plot as we have to plot a box plot graph. Data is equals to gc underscore data, and x is equals to num. And then again we'll plot a graph using plot.show, and you can see this is called the box plot. Here it shows you the mean, median, maximum, and minimum values in a single graph. Here, okay, after that we'll go for normal distributions. We will be discussing about normal distributions. For this, what we'll do, we'll use a figure, and we have used multiple axes over here that are equal to plot.subplot. Again we are using subplot that we used for smaller axes that can exist together in a single figure. But with this we have used 4 and 1. What does this represent? 4 here is representing the number of rows, and 1 here is representing the number of columns. So we will be using 4 rows and 1 column for a graph, and then we have used figure size, that is 18x, to keep it small and intact. Then we have used dot dist plot. Sorry. Why we use dist plot? We use dist plot for representation of univariate data sets. Then we have used gc underscore data, that is the variable that we have saved a file in. We are using 4 columns: age, credit amount, duration, and job. So in this we have the values they'll be using will be from ax is equals to ax1, ax is equals to x2, ax is equals to x3, and ax is equals to x4. Plot.tight underscore layout, and then we'll use plot.legends. You can see it is showing no handles will label found on the plot in legend. To plot in legend. Why is it showing this? Because in this array, in this data set, it is not able to find any label over here to put it as in legends. That's why it's showing an error over here. After that, we running this command, you can see these are multiple number of data over here. We can see there are four graphs because we use four columns and represented it in a different graph. We didn't represent all of them in a single. We can do that as well as we did, as I showed you before, but as we're using different techniques, so so we'll be using different techniques. Obviously, we can represent your data in multiple types in multiple graphs. These graphs, we will be talking about data pre-processing. What is data pre-processing? Processing is a technique or a method used for converting a raw data into a clean data set. So analysis with label encoder. We'll do analysis using label encoder. What is label encoder? Label encoder converts the label into numeric form so as to convert them into machine readable form. Machine learning algorithm can then decide in a better way how those labels must be operated. So what will it do? All the labels now will be converted into zeros and one. I'll show you afterwards. Encoder that we have created. For using label encoder, we have to import it from sklearn library. We use encoder as a variable and label encoder over here. We will run this function over here to convert all the raw data into numeric ones. For cat and categorical, GC underscore data cat is equals to encoder dot fit underscore transform. Now what will we do? Fit method is used for training the data. Now the data that we have we'll train it and fit the data. What will it do? The model will learn mean and variance of each feature represented in a data. After performing this function fit underscore transform, the data set that we have will learn the mean and variance of each feature in its data. Let's see what happens over here. You can see all the values over here. All the values over here have been converted into numeric form. You can see this, and now our data is trained, and it knows the variance and mean of each feature present in this data. So this is how we are training a data step by step, and then finally, so at the end we can work on it using different classifiers. How many classifiers can be used? There are a number of classifiers that we'll be discussing afterwards. First, before that, we'll replace values. What do you mean by replace values? There is a common named risk. Let me show you again your data. See here you have this data risk that is having good, bad and good, bad tags in it. So we can convert this text into numbers. How can we do that? See, what will we use? GC underscore data. We placed the name of column that we have to work on. Dot replace. Dot replace is the function that is used to replace a certain text or certain data with another value. The value that will replace it, the word good will be replaced with the value 1, and the word bad will be replaced with the value 0. In place is equals to true. What does it will do? It will return nothing, and the data frame is now updated. It will do nothing to the data and help in updating our data from this text to these values. Again, we use gc underscore data dot head command. Why we use this command? Just to see for top 5 rows of a column and check whether if it has worked or not. You can see now the regs column is having 1 0 1 1 0, in place of good and bad. Then we'll work to get duplicate data from original dataset. What is duplicate data? For duplicating the data, we'll create dummies. What will dummies do? Dummies will convert data into zeros and ones as well. GCD underscore dummies. We have created a variable over here. We have used pd.get underscore dummies. This is the command that we'll use to get the dummies, and we want dummies from gc underscore data from this file that we have created. Now gc underscore dummies, the variable that we have saved are all the data in dot head. Now what happens? Let's see. Dummies will also replace our text with ones and zeros as you are doing with the replace command. In replace command we had to write the variable and the values that we have to convert it into. But using dummies, we don't have to give it the variable or sorry, the text or the values that they had to be converted in. It will do all the work by itself. Now what we are doing, we will be showing duplicates with bar plot. You all know what is bar plot. You can see this type of graphs are called bar plot. We are again using plot.figure to plot the figure that we had. Fig size is 18 into 8. GCD underscore dummies. Now what we're doing, we are plotting these dummies, the variable that we created over here. We are using the file that we have created over here. Now gcd underscore dummies dot correlation by risk dot sort values. Ascending is equals to false. What does ascending is equals to false means? Ascending is equals to false will sort this data in descending order. Okay, if we wrote over here false is equals to true, I'll show you what happens. Just wait for a minute. See, it's now sorted in ascending order, but we'll keep it in false. It's up to you. You can do as you like. We use dot plot to plot all these things in a graph, and what kind of chart we are using? We are using bar use, so you have to write it over here that what kind of graph do you want. As we have, why? Because we have not written anything over here, whether we are using box plot or we are using heat maps. Anything is not written over here, so you have to tell it that what kind of graph you are looking for. You can see all the columns are here, and it has been plotted along over here using risk on the y-axis. Then making variable x, y, and drop tricks column. Now what we are doing, we will create a variable named y and x, and we will drop the column risk. Y is equals to gcd underscore dummies. That is the column that that is the variable that we are using now, and risk dot value. We saved all this thing in y. Now what we're doing, we are in x. We again use the same variable gcd underscore dummies. Now we are using dot drop as we used before. I told you. Now we are dropping column is equals to risk. Now what we'll do, we'll drop this column of risk. So in y we have the file that is having the variable risk, and in x we have saved a file without the column of risk. After that, what we will do, we will predicting the risks. Now after all the cleaning has been done, we'll start the prediction. Predicting the risks, what will we do? Train test splitting. What does this mean? Train test splitting will take a loaded data set, and then it will split it into two subsets. How will it be done? Model selection to work on a data. Now we have used x underscore train, x underscore test, y underscore train, y underscore text is equals to model selection dot train underscore test underscore split xy test size and random state. What are all these? Xtrain contains the value of the features. Ytrain contains the target output corresponding to Xtrain values. Xtrain contains the values of the features be treated. And then we have test size. What is test size? Test size defines the size of text that random state is the object that controls randomization during splitting. Okay, so splitting, why is splitting important? Splitting is important for unbiased prediction. So we can have the prediction that is unbiased. So what we'll do, we have created two subsets now. We'll work on one, and then using those analyses that we have performed on one data set, we'll try to predict the output or the results of the other subset that we have not introduced in the data. Now let's see the shape of train test prediction. So again, we are using dot shape with it. All the text train, text x test, y train, y text. Dot shape to see what to see the look of a data as we have done before. It is showing that X train contains 800 rows and 9 columns. Y text contains 200 rows and 9 columns. X train shape has 800 rows and Y test has 200 rows. So after this, what are we moving on? We are moving on to import some more libraries. Why are we importing these libraries? Because now we have trained our data enough. Now we'll work a little more, and then we'll be able to use these Gaussian, Bernoulli, and multinomial classifiers on our data. Let's move on. Model fitting and evaluation. We'll be using Gaussian naive Bayes. So in every classifier we have to fit the data accordingly, and then we'll evaluate the results. So for Gaussian NB, we have created a variable GNB is equals to Gaussian NB. Gaussian NB is the function, and dot fit, we'll fit our data. And what are we using? X train and Y train. Over here we'll fit this according to Gaussian naive Bayes. Prediction is the variable that we have created, and dot predict is used to train model predict the label of a new set of data. It will give us the prediction of new set of data. And what will it predict? It will predict a new set of data from X text. Now another thing we have in this data is making a classification report of models to measure the quality of predictions from a classification algorithm. So we have defined a function over here, that is classification underscore report model. Prediction is equals to model dot predict. Now we'll predict a new set from X text. Trend up prediction accuracy. Now we'll see how accurate the data can be. Accuracy, we have created a variable. It is equals to metrics dot accuracy. Set metrics dot accuracy underscore score y text dot prediction. So in this statement, what we are doing at dot accuracy underscore score compute the subset accuracy of y text and predictions. Then we have confusion matrix over here. Matrix of confusion is used to it takes in the list of actual, predicted, and an optional argument to specify order. It will also work on y tests and predictions. Then classification, matrix dot classification. It calculates the performance matrix like precisions, recalls, and support. Then we'll print all these things accordingly, and then we have over here. Then we'll use classification underscore report GNB. What is it? This will produce a classification report of our GNB, that is Gaussian naive Bayes. You can see it has generated a report over here. The model accuracy is 0.7. It created a confusion matrix as we had given it a command over here. Then it also created a classification report over here for us that got precision, recall, first score, and support, as I told you before. Now it's also showing us the average and total. Now the second thing we have is to plot confusion matrix of predicted models. Now, as after the predictions, we have made a prediction over here using a let me show you again. See, we have made a prediction over here. Now what we'll do, we'll plot confusion matrix using those predicted models. So we gave a class underscore name. We created a variable over here giving the values ones and zeros. We created a function def plot configuration matrix, y-test, prediction test, and class names. We'll be taking these three things to plot our confusion matrix. What is confusion matrix? Summary of a prediction results on a problem. The number of correct and incorrect predictions are summarized with counts values and broken down by each class. This is called a confusion matrix. Our confusion matrix will be created using y-test and prediction test. Fig ax is equals to plot dot subplot. Why we are using dot subplot? We are using dot subplots. Dot subplots takes in 3 arguments and create a layout of your matrix, putting them in rows and columns. Then we use tick marks is equals to np dot range. Tick marks is the variable over here. Np dot range. Why we use np dot range? Because it returns the array object containing evenly spaced values within the given range. And then we have over here len class names. Len will give the length of the list that is saved in class underscore names. Plot.xtext. What is plot.xtext? Plot.xtext and plot.ytext. What will it do? It will set the current text location and label the axis. Then here we have sns.heatmap, pd.dataframe, confusion matrix, and not is equals to true. cmap is equals to the color, and fmat is equals to g. As I told you, and not is the annotation. Cmap is the color that we'll be using for our confusion matrix, and then we have fmt, telling it all the things that are required to create a graph. We'll use plot.height underscore layout, plot.title with the title that we are giving it in as confusion matrix, that is y is equals to 1.1. Plot.label is equals plot.y label is actual label, and plot.x label is predicted label. We have taken actual and predicted values, as I told you before. We take actual, predicted values for confusion matrix. Then we use plot.conf underscore matrix as a variable, and we are plotting using y-test, prediction, and class names. Here you can see we have predictions, predicted label, actual label, and the title it's showing us confusion matrix. And here we have our confusion matrix displayed. Then making ROC curve function. What is ROC curve function? ROC curve is a plot of a signal against noise. true positive rates against false positive rates. The model performance is determined by looking at the area under rock curve. I don't know if you call it rock curve or RC curve. I'll be calling it rock curve, okay? So we have defined a function over here, that is the plot underscore rock model 1 x test and y test. Then we used another variable over here, and we use model dot predict for doing the prediction underscore proba. The proba gives the probability for the target in array. In array found, the number of probability for each is equal to the number of categories in targeted variables. Then we have FPR, TPR and threshold. FPR and TPR is equal to thresholds. What are thresholds? Threshold is the predicted probability of an observation belonging to the positive class. Then it is equals to matrix dot rock underscore curve. Rock underscore curve is used to obtain the true positive rate and false positive rate at different thresholds. The thresholds that will be using is y test and y pred proba. Plot dot plt dot plot is equals to 0 and 1, 0 and 1, and k minus minus. Plt dot plot for FPR and TPR label is equals to NB. Plot dot x label, plot y label, title, and then finally plot dot show. Plot underscore rock GNB x test and y test. Let's see how our graph is being displayed of a rock curve. You can see this graph is a straight line, and this is the rock curve. The area under this rock curve, the area under this curve is what we have worked out. So, Naive, we have Bernoulli-Naive Bayes theorem. We will be working on it as we create G and B for Gauss-Naive. We will be creating B and B variable for Bernoulli-Naive, and it's equal to Bernoulli and B. This is a function that is used in Bernoulli and B theorem. We use dot fit to train the data x train and y train according to Bernoulli and B. Then we'll again use prediction is equals to B and B dot predict to predict the x text. Then we use classification underscore report B and B. Again, we are using the classification. Why we use classification? It is used to measure the quality of prediction from a classification algorithm. As I told you before, we'll be doing the same procedure for every classifier. Now, after classification report B and B, in this bracket you will write the name of the variable that you have saved your classifier in. Then you can see it has given you the result. The model accuracy is now 0.71. It was 0.7 before in Gauss-Naive theorem. After a classification report, we'll again plot a matrix, a confusion matrix. Again, as you can see that we have not done anything, or we have just written plot underscore confusion matrix y text prediction class name. Why we did this? Because we have already done all the steps required to plot a confusion matrix over here. Sorry, not over here. Over here. You can see we have done everything required to plot a confusion matrix, so that we don't have to do it again and again. We are just using using y text prediction and class name over here. Why we are using these, as these are the same variables that we had used before, so it should give the same variable? No, because we are now training this x train and y train now according to Bernoulli. So the values in the values in x stat prediction and class name have been updated according to Bernoulli theorem now. So this is the confusion matrix, and now again, as we had not to do anything for confusion matrix. We just wrote a simple statement. We'll go for RC curve as well. We'll not have to write the whole procedure again. We'll just write plot underscore RC and the terms that we want to be plotted, and the graph will be here. This is the one-time process. I'll show you again. This is the one-time process that you have to do. You will not have to repeat it again and again for a different classifier if we are doing all the work in the same file. Okay, if I'll be doing all this work for different data sets and different files, then obviously that is a common thing that you'll have to do, write everything again, as all the data sets create a different type of data sets. Now we are moving on to logistic regression. What is logistic regression? It is used to predict the probability of a categorical dependent variables. So for this we will have to import logistic regression from sklearn.learn underscore model. This is the library that from which we will import logistic regression. LR is a variable that we will take for logistic regression, and again we will fit the data according to logistic regression. Then we'll use the dot predict again to test the to predict the data in XText. Then we'll create classification report for logistic regression. We're using the same format. Now see, the model accuracy over here is also 0.71 as for Bernoulli's. This is the confusion matrix that we created. Again, we are not writing all the steps again, because we have already done all the things. This is ROC curve for our LR logistic regression data. Then we have KNN classifier. A KNN classifier is lazy learning algorithm. It does not make any assumptions about the underlying data. It creates imaginary boundary to classify data. When new points come in the algorithm, it will try to predict that to the nearest boundary line. We are using the same format. We are creating the variable, using the classifier to fit in. Now you can see here we have an underscore neighbor is equals to 7. What is this doing over here? It is the argument for the number of neighbors that we'll use. We are using 7 neighbors over here. Dot fit. We'll fit these two datas again according to the k-neighbor classifier. Then we'll predict it, and we are again creating the report for KNN k-neighbor classifier. Now the accuracy you can see over here is 0.67. You can see all the classifiers are giving different types of model accuracy. Now after creating classification report, we'll create a confusion matrix over here. You can see we are using same actual label and predicted label, as we have not changed anything previously in our code. We are just using the data from our updated classifiers to create different confusion matrices and create our ROC curve. For ROC curve, we are just changing the variable over here before x text and y text to plot the data according to the recent classifier. Then we have decision tree classification. What is decision tree classification? It is a two-step process, learning and prediction steps. The model is developed based on given training data. The model is used to predict the response for given data. Now the data that we have trained will be used here in making a decision tree. From sklearn.tree we'll import decision tree classifier and plot underscore tree. DTC is the variable that we have created for decision tree classifier is equals to decision tree classifier criterion is equals to entropy. What is criterion? Criterion determines how the impurity of a split will be measured. You know we had splitted a data. Now we'll determine how the impurity of this split will be measured, and we have max underscore depth is equals to 3. Maximum depth to it determines maximum depth to which each tree will be built. A single tree will stop splitting when there are no more splits that satisfy the parameters. Then we have again used dot fit over here to fit our extraneous Vitron according to DTC, that is decision tree classifier. Then we are plotting a decision tree. To plot our decision tree, now we have used a different code, as we are not anymore working with the ROC curve or confusion matrix. We'll use plot.figure. Again, we have moved back to the path where we started our graphs from. Plot.figure. The figure size that we have used is 20 by 10. That is width and height. Plot underscore tree, we are using DT plot underscore tree, we have imported from here, you can see that, and we are using DTC font size 9 and filled underscore tree. Font size 9 is we have kept it for the data that will be displayed in the boxes in decision tree. Why we use filled? It is to return input as an array with masked data replaced by a filled value. Then again we are using plot.show, and here you can see this is our decision tree. If you cannot see what's written over there, I'll increase my font size to maybe 15. Let's see what happens. Okay, what happened? Okay, wait a minute. Decision tree, we will use prediction is equals to DTC.predict as we used before for our Rust classifiers. Use Xtest for prediction. Classification report over here, and it is showing the accuracy 0.665. You can see the report over here, confusion matrix. Then we are plotting confusion matrix for this. All these things are going on same format, on same codes. Nothing has been changed. We are just changing the name of DTC, and the rest are being updated accordingly by themselves. We don't have to give the inputs again and again. Then we have random forest classification. What is random forest classification? It is an estimator that fits a number of decision tree classifier on various subsamples of the dataset and uses averaging to improve the predictions. Now from sklearn, what happened? Please stop. So from sklearn.assemble import random forest classifier, we'll import this from this library. Then RFC, this is the variable that we have created for random forest classifier. We have used estimator is equals to 200. This n underscore estimator is used for the number of trees you want to build before taking the maximum voting or average of predictions. Then we'll fit this data according to RFC. Then we'll do the prediction on it. Then again we'll create a classification report, and the accuracy now is 0.695. You can see this classification report over here for random forest classifier. Then we plotted confusion matrix for it using the same format and ROC curve. Then we have features importance of RFC. Features importance of RFC describes which features are relevant. It can help with better understanding of solve the problem and lead to model improvement. Now we have created importance is equals to RFC dot features underscore importance. This is used to score assigned to the features of machine learning model that defines how important is a feature of model's prediction. Then we are sorting it. Print sorted feature importance. We will print this as a heading as it is in double inverted commas. Then sorted underscore feature underscore importance. This is the variable we have created is equals to sorted. This will sort our list. Then we have use another function over here, that is zip. Zip takes the iterable, aggregates them in a tuple and returns it. Then we have list over here to show the list of X strings. Reverse is equals to true. That means reverse creates a reverse iterator, then iterate through the elements in a string in reverse order. Then we'll print this variable over here. You can see this is the output that we have got. Then we have feature underscore importance. We have created a different variable here, and we are now using pd.series. pd.series is a one-dimensional labeled array capable of holding data of any type. RFC.feature importance. Feature underscore importance. Then we have index is equals to x string dot column dot sort values dot sort values ascending is equals to false. Now we have ascending is equals to false. That means it will again be sorted in descending order. We have over here plot dot figure. Again we are plotting a figure using the sizes 50 and 10. Then SNS dot bar plot. We'll be plotting our chart in a bar plot. X features underscore important and Y feature underscore important dot index. Why we have used dot index? To search for given elements from the start of the list and return the lowest index where the elements appears. You can see this is the result of our feature importance of RFC. Then we have RW's classification, or you can say ADA post classification. This classifier is a meta-class estimator that begins by fitting a classifier on the original dataset and then fits additional copies of the classifier on the same dataset, but where the weights of incorrectly classified instances are adjusted such that subsequent classifiers focus on difficult cases. Now we'll again have to import this from sklearn.assemble. Now, and we have created a variable abc is equals to area boost classifier. We will fit our data x train and y train according to this classifier. Then we'll predict the data, and again we'll use our classification, and classification report will be generated, and the model accuracy is now 0.73. I think this is the highest accuracy that we have attained till now. We haven't got this much accuracy from any classifier yet. We have again plotted a confusion matrix for this, and then again RFC curve. Then this is the last classifier that we have, that is X gradient boosting classification. This is a group of machine learning algorithms that combines many weak learning models together to create a strong predictive model. Decision trees are usually used when doing this gradient boosting classification. Again, import this from sklearn.assemble. GBC is the variable that we have created. You can use any variable you like, then it will be equal to gradient boosting classifier dot fit, so that we can fit our data according to this classifier. Then we'll predict the data, then we'll create a classification report, and this is showing 0.725. Our previous classifier gave us, wait a minute, let me go back. Our previous data gave us the accuracy of 0.73, and this is giving us accuracy of 0.725. Then we plotted a confusion matrix, then ROC curve for this, and that's it. We have talked about different classifiers, number of classifiers I have discussed with you. All you have to do is to create a code for it. Once you have created a code, you can use any classifier you want, and you don't have to generate the code again and again. Just it's a one-time work that if you have done correctly, you will be able to create or predict your data using any classifier you want. We have discussed about the different type of graphs in this. We have discussed how to clean our data. We have discussed how to fill our null variables, how we can replace our text with numbers, how we can create dummies. I hope this was helpful for you. At the end, I have written the summary of visualization that cars, radio, TV, and furnitures and equipments made more than 50% of the total risks and has the highest distribution of the credit issue. The rest of the purposes were not frequent purpose and applying for a loan. Cars and radio TV purposes were the less risky and the operative perspective, since it had the widest gap between good and bad risks. So we can say that using these different classifiers, what we have predicted, this prediction will be almost 95 to 98% correct. If you have worked on your data properly, it will give you almost 95 to 98% correct result that will be applicable in future on that data. Whoever will work on that data, or if some company uses that data, the data that the prediction that you have made would be 98% correct almost. Thank you for watching my video. I hope you liked it. I hope it was informative. If I have done anything wrong, you can tell me in the comments below. Take care and Allah Hafiz.